Hi everyone, my name is Mia, this is Juan Miguel, and we are here to share a seed of a research idea that neither of us, again, are actually working on, focused on the incorporation of quantitative frequency content metrics in probabilistic seismic hazard analysis.
Well, one of the most critical causes of structural collapse during earthquakes are the high dynamic displacement amplifications triggered by resonance. When I was working as a structural engineer, other colleagues and I were always wondering about how we could more explicitly account for these effects in our seismic designs. Modern design codes account for these effects through spectral shapes and for local side effect amplifications through metrics such as BS30 values. But the question here is how or can we more explicitly account for these effects in seismic design?
So when we were thinking about how to kind of capture this effective frequency content, we tried to frame it in the same way you frame a probabilistic seismic hazard analysis, which is based on the probability of a certain intensity metric given rupture and site characteristics. So we tried to kind of recreate that process here for frequency content. So given a certain rupture in site, what kind of frequency contents are likely to occur? So we split this project into two focuses, the first being on a statistical analysis of ground motion frequencies, and then the second being on how to actually interpret and share those findings with practicing engineers. So moving on to our first focus here, we are hoping to use existing ground motion recordings to kind of assess the predominant frequency contents of ground motion time histories. We want to determine if there are certain relevant statistical information for understanding and predicting frequency content. So this could be things like certain site characteristics, certain rupture characteristics, anything that could contribute to a certain frequency content being more or less likely in a given scenario. We're hoping to develop some kind of probability model based on rupture and site characteristics to predict likely frequency contents.
Well, the second part of this study would be intended to try to find the equivalent of seismic hazard curves mapping mean annual rates of occurrence to frequency content values. And as a relevant part of this stage of the study, these frequency content values would be mapped to not an amplification, dynamic amplification factor. In this case, So unlike the traditional probabilistic seismic hazard analysis framework, here we will try to find the frequency content values that maximize the mean annual rate of occurrence, which could be considered as the most likely frequency content values to be observed at this site. And these selected frequency content values would be mapped to dynamic amplification factor envisioned to affect the PGA values at the site of interest. These PGA values could be obtained from the standard probabilistic seismic hazard analysis framework. And these dynamic amplification factors could be affect the PGA values to obtain the spectral acceleration ordinate values at that period of interest. Finally, the design value would be the maximum between this alternative spectral ordinate value and the one coming from the current design code spectrum.
An alternate way to kind of interpret these likely frequency content values is to use it as a filter. So there are a lot of different things we filter and select ground motions for, intensities, durations, etc. And we could also use likely frequency content as another filter, either in the context of ground motion models or for selection of ground motions used in nonlinear structural analysis. So as a final note, we wanted to talk a little bit about the project scope. This is definitely a longer multi-phase project, but there are no experimental components, and we're using all existing ground motions, so it's mostly human and computational cost. And finally, although this is an academic study, we're hoping to make it relevant for practicing engineers. Thank you so much.